Dear student, I am Dr. Prakash Mungli, Professor of Biochemistry. So, in this lecture, I will be going over plasma proteins, chemistry, functions and clinical applications. So, in that respect, initially I will introduce you to plasma proteins and then I will take you into details on one of the major plasma protein, that is albumin. Let's get into the details. Plasma contains over 200 individual proteins that are structurally and functionally different from each other, and the plasma concentration of these proteins, it can vary from 6.3 to 8.8 grams per 100 ml of blood. And these plasma proteins, they can be broadly divided into three types. One is albumin, other is globulin, and the third is fibrinogen. Now coming to the concentration of these three major plasma proteins in the blood. Albumin, it amounts to 3.6 to 5.4 grams per deciliter. So we can say roughly 3.5 to 5.5 grams, just to remember the number accurately. And then the globulins go from 1.8 to 3.6 grams per deciliter. So we can say 1.5 to 3.5, just to have that number. And fibrinogen, it goes from 0.18 to 0.36 grams per deciliter. You say less than 0.5 grams per deciliter, just to remember roughly 0.2 to 0.5 or 0.4 grams per deciliter. Now, the globulin fractions further down can be divided into alpha globulin, beta globulins and gamma globulins. So, the plasma globulin concentration is 1.8 to 3.6 grams per deciliter, and within that we are classifying alpha, beta and gamma globulins. So, going by this particular percentage here, that is the amount of albumin, globulins and fibrinogen present in the plasma, going by that, the major protein, plasma protein that you can see here is the albumin. And then comes the globulin and then comes the fibrinogen. Now out of globulins we have alpha, beta and gamma globulins. In that, all of these proteins, whether it is albumin, globulin or fibrinogen, all of them are synthesized in the liver except gamma globulins. And also note that plasma is the soluble fraction of the blood which contains all plasma proteins, including fibrinogen. So, just to differentiate what is the difference between a plasma and serum. So, plasma is the watery thing that is there in the blood, including proteins. So, it is water plus a protein including fibrinogen, and serum is, it is the clear solution, that is water, remaining on top when a blood clot forms before centrifugation, and the supernatant no longer contains fibrinogen, and some other clotting factors are consumed as well in the clot formation, right? That means it is a water. We'll have proteins except fibrinogen and other clotting factors. So you don't find fibrinogen and other clotting factors in the serum because all the blood clot has been made. This is the difference between plasma and serum. So, for most diagnostic tests, either plasma or serum can be used. Remember that. Coming to separation of serum proteins. Individual proteins present in the serum or plasma can be isolated by different techniques based on their size, shape, net charge and solubility. So, using this methods in separating proteins present in the plasma or serum. So some of the techniques that are commonly used are a stepwise precipitation of proteins with salt, that is known as salting out technique, or we can use a chromatography, which can be cation and anion exchangers. Chromatography can be done, or it can be fractionation with organic solvents using like ethanol or ether, or it can be gel filtration method on media with specific porosities, and that will separate proteins based on the size, or it can be electrophoresis, which will separate proteins based on the size and also charge. So out of all these, one of the separation techniques that is important is the electrophoresis, especially to separate serum proteins. So serum protein separation can be done effectively by using electrophoretic technique. So what we are going to do in the electrophoresis is a paper or agar gel electrophoresis is used, where a barbiton buffer which is having a pH of 8.6 is used, and it will give a separation of plasma proteins based on their size and the charge, because when the pH of solution like 8.6 is used, so most of the deprotonation is going on over a polar side chains of amino acids, and in their deprotonated forms they are all anions, and based on the number of anions present in these proteins, they all move towards the anode, which is a positively charged diode. So all the molecules which are having a positive charge, like which are not went deprotonation or something, so they will be present nearer to the cathode, that is the negatively charged diode, right? So all anions will move towards anode and all cations will be nearer to cathode, and also this separation is dependent on the size of the molecule, not only the overall charge and also the size of a molecule. So using that, so when the serum electrophoresis is done, as it is shown in the figure here, so albumin having a highest negative charge, and also the smaller the size, it will move all the way towards the anode. See, the positive diode is anode here. Make sure you remember that. Anode is positive diode. Okay. Cathode is a negative diode. Cathode is negative. Alright. Always by convention, sample is applied at the cathode side. This is the point of sample application. I am highlighting that here. Sample is applied here. Now, when the electricity is passed from cathode to anode, there will be separation of serum proteins according to their overall charge and also size. And also remember, the pH of the media that we are using is 8.6. At that time, when the amino acid side chains are undergoing deprotonation because of the pH-pK relation, protonation and deprotonation and all that, so any molecules that have got higher negative charges, so they will all move towards anode. So albumin having a higher negative charge and being a smaller size, it will move faster towards the anode, and then followed by we have alpha 1 globulins, alpha 2 globulins, beta globin, and the last will be gamma globulin. So this is how electrophoretic separation will be going on using a serum sample. Alright, now what if this is a serum electrophoresis, as the title says. What if a plasma is used as a sample for electrophoresis? So the difference here is, if the plasma is used instead of serum, a band of fibrinogen fraction is seen between beta and gamma globulins. So here is the beta and gamma, and you will see a band of fibrinogen down here. Okay. So let me just redraw it or edit this, Raju. So a band of fibrinogen will appear between beta and gamma fraction. I'll just make it small because the amount of fibrinogen is very, very less. So this will be fibrinogen. And this happens only when plasma is used for the electrophoresis instead of serum. Just remember the difference there. So for all practical purposes, so we use a serum for electrophoresis rather than plasma. So this is the electrophoretic pattern for normal serum sample. Now let me explain you what is albumin-globulin ratio or AZ ratio. The normal serum albumin concentration, as we have already seen, it is 3.6 to 5.4 grams per deciliter, and also for globulin we have seen it is 1.8 to 3.6 grams per deciliter. And if you take the ratio, the normal albumin globulin ratio, it will come around 1.36 as a mean value, or we can put it as a range between 1.2 to 1.6 as the normal albumin globulin ratio. So this ratio, it will be lowered in various conditions where whenever a serum albumin concentration falls, which is referred as hypoalbuminemia, decrease in albumin, is called as hypoalbuminemia. Whenever you come across a term emia, remember that's in the blood. That's just a general way of understanding. Albuminemia, emia, right? It's in the blood. Urea, albuminuria appearing in the urine. That's how you can understand that. Okay, so decrease in the albumin leading to albuminemia, hypoalbuminemia, and when globulin concentration rises, that is called hyperglobulinemia. So increase in globulin causing leading what is called as hyperglobulinemia. Look at emia now. That's in the blood. So that means excess globulin and decrease albumin. So numerator albumin is decreased, denominator globulin is increased, so ratio falls. So that's what happens whenever albumin decreases, globulin increases in certain conditions. Now let me explain you some of the disorders where this ratio is altered. So the mean albumin globulin ratio that we have seen is 1.36, and this can be decreased in some of the disease conditions like given below here. So in the nephrotic syndrome, where albumin levels are low and globulin levels are high, so ratio will decrease. So because of low albumin and high globulin levels. In malnutrition, what happens is albumin levels will decrease because protein intake is down. So decrease in albumin eventually lead to change in the albumin globulin ratio. Liver disease also, there will be decrease in albumin. Chronic infections, there will be increase in globulin, and that will change the ratio. And multiple myeloma, globulin rises, that will also change the ratio. So like this, albumin globulin ratio can be altered. And also note that abnormal electrophoretic pattern can also be seen in conditions like multiple myeloma, where a sharp distinct M band appears in a gamma globulin region. So when serum protein electrophoresis is done, so in multiple myeloma patients' serum, in the gamma globulin region, so there will be a sharp M band appears, and that's because of monoclonal gammopathy, which is seen in multiple myeloma cases. That's an abnormal electrophoretic pattern. And also in infections, alpha 1 and alpha 2 bands are increased, indicating there is an infection. So that type of abnormal electrophoretic patterns can also be seen in certain diseases other than changes in the albumin-globulin ratio. Now let's move on to see details on the major plasma protein that is called as albumin. So albumin is most abundant plasma protein, as half of the total plasma protein is albumin, and also the size of albumin is 69,000 Dalton, and it can be easily filtered by the glomerulus, and half-life of albumin is 20 to 25 days. But the thing is, due to its low molecular weight, it is one of the first protein to appear in the urine after renal damage. But under normal conditions, albumin is not filtered, although it has got a relatively low molecular weight, that is 69,000 Dalton or 69 kilodalton, because we can write 69,000 Dalton as 69K Dalton, right? It's relatively low molecular weight protein, but not filtered into the urine under normal conditions. It happens only when there is a renal damage. Because under normal condition, because of the higher negative charges that are present in the albumin, so albumin is, the filtration of the albumin is prevented by heparan sulfate and type 4 collagen, all these molecules which will hold that based on the charge selectiveness. That's why it is not filtered. And also albumin, it is a simple protein consisting of a single polypeptide chain having 585 amino acids, and there will be around 17 interchain disulfide bonds, and it is produced exclusively in liver. A healthy liver can synthesize about 10 to 15 grams of albumin per day. So because of this, albumin is used to assess a liver function. Now let's move on to see some of the functions of albumin. Albumin, it maintains oncotic pressure. It is one of the important protein present in the plasma that will regulate osmotic effect and fluid balance in the blood vessels. Because whenever there is hypoalbuminemia, that is decrease in the albumin level, that will result in significant reduction in osmotic pressure of the blood, and that leads to a movement of water into interstitial space of the extremities and other parts of the body, and that causes swelling, leading to what is called as edema. That's why normal albumin concentration is important to maintain the oncotic pressure, thereby fluid is not going out of the blood vessel into the extracellular matrix. Because when there is lower albumin levels in the plasma, that will change the oncotic pressure, thereby water starts to move from the blood vessel into the extracellular matrix, leading to accumulation of water in the extracellular matrix, especially in the dependent areas, and that causes what is called as edema. Edema is nothing but it is an accumulation of water in the extracellular matrix, especially in the dependent part. Dependent part means when some person is standing, ankles are the dependent, foot and ankles are the dependent part. Now, that's one of the function of albumin, that is to maintain normal oncotic pressure. Albumin is one of the important transporter of variety of molecules in the blood. Albumin is involved in transport of 40% of plasma calcium. It is involved in the transport of water-insoluble unconjugated bilirubin. It transports steroid hormones, free fatty acids, and many non-polar drugs are transported by albumin in the plasma. And also, albumin, it is circulating reservoirs for hormones, because many hormones, they make complex with albumin, especially the steroid hormones. Thereby, it will prevent these hormones from their loss by renal filtration. And also, albumin acts as a buffer in the blood, because albumin, it contributes to maximum buffering capacity in the blood compared to other plasma proteins, and it gives a about 15% of total buffering capacity of the blood, and largely that is because of presence of certain amino acids in albumin like histidine, which has got that buffering capacity. And also albumin has got a nutritive function. That means the degradation of albumin is an important source of some of the essential amino acids during malnutrition. That's why serum albumin concentration will decrease whenever protein intake is less, because the albumin is degraded to give those essential amino acids for some of the most essential protein synthesis needed by cellular metabolism or cellular function. And that's why measuring serum albumin levels will measure person's protein nutritional state. So these are some of the important functions of albumin. Now let's move on to see some of the disorders where albumin concentration is altered. So increase in the albumin concentration is referred as hyperalbuminemia, and decrease in the albumin concentration is referred as hypoalbuminemia. So here let me explain you hypoalbuminemia first, and then I will come to hyperalbuminemia. So what are the causes for hypoalbuminemia? So the first cause that I would like to explain here is the renal cause. Renal causes for hypoalbuminemia. An important disease here is nephrotic syndrome. A marked fall occurs because of massive urinary loss of proteins in nephrotic syndrome, and total serum protein concentration here in this disease will fall below 4 gram per deciliter. See, the other cause for hypoalbuminemia can be gastrointestinal causes, where there will be malabsorption of proteins leading to hypoalbuminemia. Example, enteritis, any kind of gastrointestinal infection, or it can be sprue, it can be steatorrhea, excess loss of fat in the stool, taking out the proteins, and any malignancies or cancer in the intestine, or exocrine pancreatic disease like cystic fibrosis. They all can lead to hypoalbuminemia. And then the protein losing enteropathy, where lot of proteins are lost out of the intestine because of the certain disorders that are going on in the intestine. So the loss of proteins from the intestine can be demonstrated by using a chromium 51 labeled isotope, which will be measured in the stool. Thereby it indicates how much protein is lost in the stool. Insufficient intake of proteins, as it is understandable, can lead to decrease in albumin levels in the blood. And hepatic causes, as liver is the only organ for albumin synthesis, and hepatic disorders like cirrhosis of the liver can lead to hypoalbuminemia. So these are some of the causes for hypoalbuminemia. And other causes for hypoalbuminemia can be severe hemorrhage, shock, burns, crush injuries, and in post-operative period where there will be increased degradation of albumin. Now let me take you into other conditions that alter albumin levels, and that is hyperalbuminemia and analbuminemia. So hyperalbuminemia means excess albumin levels in the blood, and that's usually because of loss of water or the fluid volume, which will lead to increased levels of albumin per deciliter because of the dehydration. Now dehydration, particularly if it develops rapidly, it results in hemoconcentration, because water is taken out and the albumin levels are same. So if albumin levels in the blood is say 5 grams per 100 ml of blood, and if you take out only the volume out, so you just take out 50 out of 100 ml, so it is still 5 grams in 50 ml. That means 5 gram in 100 ml, 5 gram in 50 ml, it is just a hemoconcentration. It looks like it is doubled, but it is the same amount which is there, but only water is taken out. So that type of apparent increase, apparent rise in albumin can be seen in dehydration and vomiting. Vomiting and diarrhea are the major causes of dehydration, and that is the one that will lead to apparent hyperalbuminemia by changing the albumin-globulin ratio that you need to be aware of. Coming to analbuminemia. Analbuminemia, it's a rare genetic disease where albumin is virtually absent. However, in this disease, edema is generally not seen, although like albumin, it maintains the colloidal osmotic pressure, that is the oncotic pressure in the blood. Here, although albumin level is virtually absent, but as a compensatory mechanism, globulin levels will be higher in analbuminemia, and that's why the globulins will take care of the oncotic pressure there. That's why the edema is generally not seen in analbuminemia. Coming to something called as prealbumin, which is also referred as transthyretin. In fact, transthyretin is referred as prealbumin because in the electrophoresis, transthyretin, it comes before albumin. That's why it is called as prealbumin. And the role of transthyretin is to bind with retinol binding protein, which is attached with the retinol. So, retinol binding protein transthyretin complex, which is a ternary complex, and that will prevent loss of retinol binding complex through glomerulus and prevent decrease in vitamin A. And that's how transthyretin works. So these are some of the details on plasma proteins, albumin, some of the causes for hypoalbuminemia, hyperalbuminemia, and analbuminemia. That's all about it. Thank you.